Hello everyone, my name is Safal. Welcome to another interesting session here at Code Heroku. In our today's video, we will be going over sentiment analysis of text data using TensorFlow. At Code Heroku, our mission is to make world-class computer science and engineering education accessible to millions of students, especially in developing countries like India. We'll be starting by understanding what is sentiment analysis of text data, and we'll see some of its applications. Then we'll be understanding the data set that we will be using in this exercise, and we'll know our objectives for this exercise. Then we will go through some of the common techniques used for sentiment analysis. Then we will look at the overview of steps involved in this exercise, and then finally we will be doing sentiment analysis using TensorFlow, which is the hands-on part of this video. Starting with what is sentiment analysis. Sentiment analysis is basically a natural language processing technique used to interpret the emotions behind text data. For example, in Amazon, we users post reviews for products, right? So if someone likes a product, he or she will post a positive review about the product. And if someone does not like the product, he or she can post a negative review about the product. So what sentiment analysis does is it will take this text data, which is in the form of a review, and it will give us an output that is going to tell us whether this review is positive or negative. So we can use sentiment analysis on different type of text data. If we will look at some applications of sentiment analysis, this technique is widely used for understanding social sentiments for trending topics. Sentiment analysis is also used by organizations and companies to understand the overall public sentiments of their products by gathering user reviews, as I gave example of Amazon reviews. So they can gather the reviews of their products from Amazon, and they can finally get to know the public sentiments for their products. Sentiment analysis can also be used to find whether a post or a tweet should be deleted and whether it follows the community guidelines or not. Right? Stock trading companies can also use sentiment analysis to find companies that show a positive sentiment in news articles. So basically, if it is showing a positive sentiment in news articles, it is more likely that people are going to buy that stock. So here also we can use sentiment analysis. So these are some of the applications of sentiment analysis. Now, if our data set that we will be using in this exercise is the IMDb data set, which contains user reviews for various movies and their corresponding sentiments, which are either positive or negative. So IMDb basically is a website where users who have watched a certain movie, if he or she likes the movie, he's going to give a positive review about the movie, and if person does not likes the movie, he can give a negative review. So our data set basically contains reviews from IMDb website and their corresponding sentiments, which is positive or negative. You'll get a better understanding of the data set when we will be on the hands-on part. We'll have a look at the data set and try to understand more about the data set. Our objective in this exercise would be to create and train a model which can classify the sentiments of reviews, whether it is positive, whether the review is negative. So that will be our objective for this exercise. Now the common techniques. So one of the common techniques used for sentiment analysis is rule-based sentiment analysis. Now rule-based sentiment analysis uses a dictionary of words labeled by sentiments to determine the sentiments of a sentence. Like you can see here, we have these words like good, great, and we have their corresponding sentiments. So we use this dictionary in which the words are labeled with sentiments, which is a real valued number, And then additionally, we have to give a set of certain rules to basically identify the sentiment of a sentence. This technique is good to use, but it becomes very complex when you have to create rules for identifying sentiments. So this technique is good, but it is very complex technique. Now, the second technique is machine learning based sentiment analysis. In this, we train ML models to recognize the sentiments based on the words used in a sentence and the order of those words. We use a sentiment labeled data set for this. So, different techniques in machine learning is like logistic regression, word embeddings, random forest, support vector machines. Now the technique that we will use in this exercise are the word embeddings technique and the neural networks. Uh, why we will be using word embeddings and neural networks is that the basic machine learning techniques like logistic regression, they are able to extract features from a sentence to realize its polarity, that is whether it is positive or negative. But these techniques, they do not consider meaning attached to each and every words of the sentence. So that is why we are going to use the technique of word embeddings and neural networks. Now let us look at some of what are the steps involved in this exercise. So we'll start by pre-processing the data. So, as I told you, we have a data set in which we have IMDb reviews and their corresponding sentiments. So, obviously, this is going to be a text data. So, text data cannot be given directly as an input to the model. We would need to pre-process the data, which involves converting this data into integers, tokenizing this data, making word embeddings of these data, and making length of each review equal. So these are some of the pre-processing steps involved. Then we will be doing word embeddings. So word embeddings basically give us a way to use an efficient dense representation in which similar words have similar representation. So in word embeddings, basically each word will be converted into a vector, basically a real valued vector of some specified length, that and the length of the vector will be specified by us. But the values of those vectors are trainable parameters. Then we will be defining the model architecture. As I told you, we will use a neural network. So we'll have to define the architecture of the model. Then we'll train the model on our data set. And then we have a different data set for testing the model. So we will be testing the model on the test data set. So now since we have an overview of what we are going to do in this exercise, now let us begin with the coding part of this exercise. So we will start by importing the necessary libraries. So TensorFlow here is needed to create the model. Keras is also needed to create the model, and Pandas is basically needed to read the data set and manipulate the data set. And NumPy here is needed for some of the pre-processing parts of this exercise. So now since we have loaded these necessary libraries, now what we are going to do is we are going to read the data set. So we have loaded the data set. Now let us have a look at our data set. So as I already explained you about our data set contains the reviews and their corresponding sentiments. So uh, we have this review and its corresponding sentiment, which is positive. There's another review, its corresponding sentiment is negative. So I have also loaded one more dataset, that is test reviews dataset. So the IMDb reviews dataset is going to be used for training the model, and the test reviews dataset will be used for testing the model. Now, since we have had a look at our dataset and we already know that we cannot pass this text data as it is to our model, so it is time to pre-process our data set. So for pre-processing, what we'll do first is we need to convert this text data into an integer format. So for that, we can map each distinct word to a distinct integer. So for example, we have many reviews in this data set and each review has many distinct words. So we are going to map each distinct word to a distinct integer. Now we already have a file that contains these mappings from uh, distinct words to distinct integers. So I'm going to load that file right now. Now, if we look at this data file, this contains different words like spiders and its mapping. So spiders is mapped to the integer 16118. Hanging, the word hanging is mapped to the integer 2348. So what will happen is uh, in this entire data set, if in any review there is this word hanging, it is gonna get converted to 2348. If there is a word woody, it is going to convert into 22992. So this is what we need this file for. Now we need to convert this word index data frame into a Python dictionary so that we can use it to basically convert our text data into the integer format. So now we have converted this data frame into a Python dictionary which contains these words as key and their corresponding integers as the value. So we have this key value pair in the dictionary named word index. Now, as you can see, we have these words like start, this UNK. So the start basically signifies the starting point of a review. This UNK signifies a unknown value. So whenever we are going to convert this review into integer format, we will need an integer encoding for these symbols also. So we need to create integer encodings for this. Now we are going to create that. So now we have created a mapping for these symbols also. Now what we do is we define a function that is going to help us encoding these reviews into integer format according to the mapping specified by this word index data file. So we are going to name that function, let's say review encoder, as we are encoding the reviews. So we name the function review encoder, and it is going to receive a text as an input. And what we'll do is, so what this review encoder function will do is, it is going to take a particular text which is a review, and it is going to map each word to an integer as specified by this data file, and it is going to return that encoding. So this is why we have created this function. Now, what we need to do is we need to split data set. As you can see that the data set contains these reviews and sentiments. So we need to split the reviews and sentiments because we need a different preprocessing for these reviews and we need different preprocessing for sentiments. So the views will be converted into integers. Sentiments will also be converted into integers, but they will have only two values. For positive, we will say 1, and for negative, we will have 0. Now we are going to split our data set. Now we are going to similar split for the test data as well. So now in train data, basically now we have the reviews. In train labels, we have the sentiments of our training data set. In test data, we have the reviews of test data set, and in test labels, we have their corresponding sentiments. So after splitting this data set, or what we are going to do is we are going to split or tokenize this string. Now, this string is right now a single string. Now, what we want to do is we want to convert this string into an array of strings, right? Because if right now we pass this string to our review encoder function, it is gonna consider this entire string as a single word, and we do not have a mapping for this particular long string. We have mappings for distinct words. So we need to split the strings on the basis of these white spaces so that we can map the individual words to integers. We are going to split the views on the basis of white spaces. Similarly, we are going to split the reviews of test data. Now the split function of Python, this split basically splits the strings on the basis of white spaces. We apply this function to each and every review. Now, if you see, now our review is basically converted into an array of strings. Initially, it was like this entire string. Now we have splitted each string. So start is a different string, this is a different string. So basically our uh, review is being has been converted into entire array of strings. Now we can use the review encoder function to basically uh, encode these string or text data into integer format. So now and our reviews have been finally converted into integers. Now if we have a look at our review, so our review has been converted into an array of integers, right? So this is what we wanted. We wanted to convert initially this review into an array of integers. After transforming these reviews into an array of integers, uh, we need to also, we need to give a value 1 to the positive sentiment, and we need to give a value 0 to the negative sentiment. So basically we need to encode the sentiments also. So we are going to create a separate function for encoding the sentiments, and then we are going to apply that function on each and every sentiment of our data set. So let's name the function encode sentiments, and it is gonna receive a sentiment. Let's say, now we can say that if the sentiment is positive, if the sentiment is positive, return 1, else, that means if the sentiment is not positive, that means it is negative. So we are going to return 0. Now we are going to apply this function on each and every sentiment so that gets converted into 0 or 1. Okay, so now we have converted our sentiments into 0 or 1. For positive we have 1, and for negative we have 0. Now still we cannot pass this data set as an input to our model, because uh, what the thing is that the different reviews are of different length, and that is gonna add some ambiguity to our input data set, and we don't want that. We want a stable data set to be passed as an input to the model for getting a better accuracy. So what we are going to do is we are going to make the length of each review equal. So basically, if the length of a review is greater than a specified length, so we'll use a length of 500. Let's say we use a length of 500, so we are going to convert each review into length of 500. So if a review is longer than 500, we are going to cut the extra part, and if a review is shorter or has a shorter length than 500, then what we are going to do is we are going to pad it. So for example, let's say a review is like this: 1, 10, 4, 6. The review has only 4 words or 4 letters, 4 words. So what we are going to do is, to make it 500, we are going to pad it with zeros. So this, we are going to just add zeros until the length of 500, right? So we are going to basically add zeros until its length becomes 500. So we are going to use the pre-processing function of Keras to basically equalize the length of each every review. Now what we are doing is, I have already told you, we are adding zeros if the length is shorter than 500. So that is why I have passed this max length is equals to 500. So this is going to cut if the review is longer than 500, and add this value that we have passed. So we have already declared the value of word index pad as 0. So if the length is shorter, it's going to add 0. And we have said that padding is equals to post. That means after the review ends, after the last word of the review, we are going to add this padding. So let us run this. Okay, so now our reviews have a padding. Now the pre-processing part is complete, but still one part is left, that is word embeddings. Now we are going to look what is word embeddings, and we are going to understand what are these word embeddings. So we know that we have converted our text data into integer format. But what happens is, this conversion of text data or different words into distinct integers, we are not able to understand the relationship between the words that have similar meanings. For example, let's say there is this word beautiful, and there is this word pretty, right? So when we convert them into integers, these words are considered as two distinct words. So beautiful will have, let's say, a mapping 13. Pretty could have a mapping 37. So these mappings are going to take these words as two distinct. But ultimately we know that these words have similar meanings. So this relationship is lost. So for that, what we do is we have this concept of word embedding, which help us to basically represent each word uh, as a vector or as an array of real valued or floating point numbers. So beautiful might look like something 1.2, 0.6, 1.8, 1.9, or something like this. Like right now, this the length of this vector is 4. We can specify the length of this vector, but the values like these values inside this vector, we do not specify these values. These values are going to be learnt while the model is being trained. So after these values are learned, we would see that these two words which have similar meanings and which are used in similar places, they will have an equal, or they will have a similar representation of uh, they will have a similar representation in word embeddings. So this is why we use word embeddings for our exercise. Now since the pre-processing part is done, now we are going to create the model. But before creating the model, what we need to do is we need to understand the architecture of our model. So, what is the architecture of our model? So, our model contains 4 layers. The first layer is the word embedding layer. Now, what this word embedding layer does is it creates word embeddings of the length specified by us for these inputs, right? The second layer is a global average pooling layer. This global average pooling layer is used to prevent overfitting by reducing the number of parameters. Now, how does it does this? Like I gave you an example, beautiful. This is some vector of length. Let's say 5. It is represented as a length of vector 5, right? Or let us say we have a review. The movie was awesome. So what we have is we will have let's say a vector representation of length 5 for each word. So this is an array of length 5. Uh, this movie will also be represented as an integer of length, vector of length 5. Was will also be represented similarly, and awesome also. Now what is going to happen is, since these words are represented as an array of real value integers and the array has similar length, so let us suppose the first index here contains 1.3, here it is 1.8, here it is 2.0. So what global average pooling layer will do is it is gonna take the average of all the values at index 0, and it is gonna store this in the final output. Similarly, it is going to take all the values at index 1. Let's say here it is 1.1, here it is 2.2, and here it is 3.4, something like that. So it is going to take the average of all these values and it is going to store that in the output. So what this does is this reduces the number of parameters, and since the number of parameters are reduced, the overfitting, the chances of overfitting are also reduced. So this is why we have a global average pooling layer. Now the third layer of our model is a dense layer which has 16 hidden units, and it uses ReLU as an activation function. And the final layer is the output layer which uses sigmoid as an activation function. Now the output layer is going to give an output between 0 to 1, which will also be a floating point value. So an output of zero point 0.7 means that the input that we have given, or the review that we have given as an input, there are 70% chances that that review is a positive review. And if the output is zero point 0.3, that means there are 30% chances that this review is a positive review. That means it is a negative review. There are more chances of it being a negative review. So let us now finally build our model. So we are going to use Keras to build the model. As I told you, our first layer is the word embedding layer. Our second layer is a global average pooling layer. Our third layer is a dense layer which contains 16 units, 16 hidden units, and uses activation function. And the final is the output layer, which is going to give one output. It uses sigmoid as an activation function. So this is our model structure. Now we have specified the length of each vector to be 16. So our word embedding layer is going to convert each word into a vector of length 16, and we have converted each review to a length of 500. So I have passed this input length as 500, and we have these other layers. So yeah, now it works fine. So we have created our model. Now after creating this model, we are going to compile this model, and we are basically gonna use Adam as an optimization function for our model. It is one of the best optimization functions for neural networks. We are going to use the binary cross entropy loss as the loss function for the model, and we're going to use accuracy as a metric to evaluate our model. So mm, we compile our model. Now, finally, since we have created the model, we have compiled the model. Now we can train the model using the training data set. So we are going to train a model and we are going to store the output after each epoch in this history variable. So we have passed the training data for training the model and the test data for validating it. Now we run it. So our model has now started training. Now, as you can see, after the completion of training, our model has an accuracy of 95% on the training data set. So our model is given an accuracy of 95%. Now let's check the accuracy on test data set. So this model.evaluate function is used to evaluate the model on the test data. So you can see that loss is 0.29 and our model is giving 88% accuracy on testing data. So now what we can do is what we can also try to see the output of our model on one of the random reviews from the testing data. So if you look at the test, these test reviews have a similar structure uh, as the training reviews. So now we are going to pick a random review from this test data set and we are going to check the output of our model on that particular review. So what we are going to do is we are choosing a random index from 1 to 1000. Now this number is totally random and we are going to pick the review at that particular location. So this is a totally random review and you can see the sentiment of this review is negative. This is the review, this is the sentiment. So now we are going to test our model one more time on this random review. So this review is basically in text format. We have already converted it into integer format, so we are going to use that. We are going to use that already converted format of this particular review, and we are going to convert this review into a numpy array, and then we are going to pass this review as an input to our model to check what the output of our model is. So we are going to use the model.predict function, and we give our review as an input to the model. Now this review dot predict is going to give us an output from 0 to 1, and as I told you, if the output is greater than zero point 0.5, then the chances of model or the chances of review being positive are more, and if the output is less than zero point 0.5, the chances of the review being negative are more. So if it gives the output greater than zero point 0.5, what we are going to do, we are going to print positive sentiment, else we are going to print negative sentiment, right? So let us run this and see. Our model gives an output of negative sentiment. So this was all about sentiment analysis. uh, Now since we have done the hands-on part, let us look what all we have learned throughout this tutorial. So we started by understanding what is sentiment analysis, and we knew some of its applications. We went through some of the common techniques that are used for sentiment analysis. We understood how to pre-process the data to basically give it as an input for a model or a machine learning model, and we also understood what are word embeddings and why do we use them, and finally we did a hands-on exercise. So thanks everyone for staying till the end. If you have any questions, please do comment in the chat below and we will do our best to help you out. We also have a WhatsApp community group, so if you would be interested in joining, please see the link in the video description.